In this video, we're just going to be talking about what a limit is. I'm going to do a bunch of examples, but I want to start off by reminding you that a limit is the intended height of a function. In other words, a limit tells you where the outputs are going or where the y values are going depending on where the inputs or the x values are headed. Okay, and I'm going to be referring to this little chart here that I made. If it's possible for you to take a screenshot of that, or maybe take a picture of it with your iPhone or whatever device you've got, and so you can keep that handy, I think it'll be helpful to refer to this little chart as we go through our limits. And just to quickly go through this, when you are finding a limit algebraically, you're going to substitute first. If you happen to get a real number, then you're done. 0 included, so 0 divided by any other number besides 0, you're going to just have 0 for the limit. If by chance you get any other real number, then you stop, because that's your limit. Okay. If by chance you happen to get 0 in both the numerator and the denominator, as we've talked about, you can factor, cancel, and then substitute again. You can try the conjugate method, and if neither of those two methods works, then you'll have to try another technique to simplify the fraction. Okay. If, on the other hand, you happen to get a constant in the numerator and you get 0, or really what you're getting is a number that's approaching 0 in the denominator, then you know that fraction's values are getting really, really big. Either positive or negative infinity is what you're going to get for that limit. Okay. And finally, if x is approaching either positive or negative infinity, then that's when you're going to want to think of the bubble concept. Okay. It doesn't have to just work with rational functions either. It could be, let's say the numerator just doesn't grow quite as fast as the denominator grows, and so you get a bigger bubble downstairs, and then, well, those limits we know to be 0. If the coefficients happen to be the same, growing at the same rate, if the numerator and denominator happen to be growing at the same rate, then you peel off the coefficients of the significant terms in both numerator and denominator, and then that would be your limit. If, however, finally, the numerator happens to be growing faster than the denominator, like for example, as x approaches infinity, e to the x divided by x, that would be a bigger bubble on top, because e to the x is an exponential function, and it grows much quicker than the x, so we would say that's a bigger bubble on top, and both numerator and denominator, as x approaches positive infinity, would go toward, would both be positive, and so we would get positive infinity. Okay, so let's go ahead and get started. A little background here. Maybe I'll just, that's what I'll do. I'll stop the video there so you have the background, so maybe you want to review that, or just go on to the next video.